Hello, my dear students. Are you there?
Yes, sir.
So please unmute yourself. I want to have a 5 minutes interaction with you people before I start solving a problem. So I request everybody to unmute yourself and I want to have an interaction. Yeah. So you have any clarification, my dear students, you can ask because the solids are very, very, very important from the examination point of view because we have only a one question which is a compulsory question which carries 45 marks. Okay, so small mistake in the solids, it will cost you a 45 marks. So therefore, you have to learn the things very clearly. Concept should be very clear, and both the sketching as well as doing it on a system, both you should do it very clearly. Because 60% of the marks is given for your sketching, and 40% is given for your printouts. So therefore, the most priority is for sketching. Okay, because solids, it definitely takes time. When we do prisms, it definitely takes some time to complete one problem. So therefore, please, if you have any clarification for the first hour or first session, what I discussed, so you can talk to me. And before I start going to the solving a problem, so anybody, you can feel free to ask the doubts and clarify your doubts. So because once I start, it's very difficult, of course. I will also clarify there, not an issue. But again, I cannot come back to the therefore, if you have any clarification anywhere, even let it be very silly, not an issue. But this is the beginning of the chapter. So you need to understand the fundamentals properly. Once the fundamentals are correct, then the rest of things are very simple. Okay, so you can talk to me for next 2-3 minutes. If you have any clarification, we will go to do. If I don't talk means I will assume that you people are understood and I will start us going to the solving. Okay, you can speak to, you can unmute yourself and you can talk to me. The time is yours now. Everybody is there? Ayush?
Yes, sir.
Yeah. Avantika, are you there?
Yes, sir.
Muhammad Tabish, Arati,
Yes, sir.
Yes, sir.
Divyashri,
Yes, sir, I understood.
understood. Harshita,
Yes, sir. I
Monica,
understood.
okay.
Yes, sir.
Nagesh, Nagesh, are you there? Navya,
Yes, sir.
so shall we proceed to the next solving the problems?
Yes, sir.
Okay, take your sketchbooks, pencil, scale, drawing instruments, whatever things is there. So I will explain once first and afterwards you can start doing. So until unless you understand, please don't do drawing in your sketchbook. Okay. So I will show one problem and how to do that. Okay. So we will take directly from your solution manual and directly we can start solving and we will go to fetch the projections. Okay. Hoping you people understood everybody. If you have any doubts, you can talk to me or you can stop me at any point and you can have a clarification. Okay. So now I will going to start with the one simple problem on projection of solids. Let us start with the prisms first. Okay. Let's start with the prisms. And of course, prisms in the sense, first we're going to start with the square prisms only. So here we have only three types of prisms to be discussed. One is a square prism, second one is a pentagonal prism, and third one is a hexagonal prism. Okay. So here the different positions we will go into discuss and we will go into of course whenever is required I will going to explain what is required for that particular problem and also I will be keep on explaining the rules of visibility. So which side is visible and which side is not visible. This is the most important thing in solids. Okay. So let me start with a problem. One simple problem. I'm going to start it now. I think you will go into understand that. Okay. I hope everybody can see this problem. Can you see the question there? What I have just displayed now?
Yes, sir.
Now, let us take the simple problem I have taken, very simplest of the simplest. Let us take this problem. A square prism, 35 millimeter sides of base and 65 millimeter axis length, rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the prism when the axis is inclined to HP at 45 degrees. So this is a typical examination problem for 45 marks. Okay. So let us just understand the problem statement first. Okay, I will just break up the things and I will go to explain each one how to take it out. Okay. And later onwards, I will explain how this problem will be solved. The first important thing, the most common mistake students will do in solids is the type of a solid. In the sense, might be there in the examination tension or whatever it might be. So they will go into interchange. Interchange in the sense, if they are given square prism, okay, so prism is given. So by tension, they will go into read it as a pyramid and they will start doing pyramid. See, everything they will do correctly. Everything they will be done correctly, but instead of a prism, they have made a pyramid. So this is the common mistake the students have done. Very good students I am talking about. So they might have got 40 out of 40 in maintenance, but they have done a very simple mistake just reading the problem. So just taking, instead of a prism, if they take pyramid, so 45 marks, not even a single marks will be given. Be careful. So please read the question carefully. Please just come to the conclusion, which is the prism, which is the solid. So once you read the problem, that projection and that solid should come to your mind. Okay. So many of the students I have seen, they have lost the marks because of just this very silliest of a mistake. So just making a pyramid instead of prisms. Please read the question carefully and start answering it. Okay. A square prism, it is a prism here, a square based prism, 35 millimeter sides base. So means in the sense, base of a square based pyramid is the 35 millimeter and the 65 millimeter axis length. So axis length means it is the height of the prism or axis length, anyone they can give it, and it rests on HP. So it's a common thing what you will go to get it. And the next thing is very important. On one of the edges of the base. So this will go into change in the problem statement. Okay, this will go into change. One of its edges of the base in this problem. Sometimes they may give one of its corners of the base. Okay, so corner I will go to deal with later. So now one of the edges of the base which is inclined to VP at 30 degrees. Draw the projections of the prism when the axis is inclined to HP at 45 degrees. So this is how they have given the problem statement. Yeah. First thing is a square prism. Remember, and the side of the prism or square is 35 millimeter and height of the prism is 65 millimeter. So this is the description of the prism they have given. And the position is coming to the position, it is been resting on HP. So of course, this is also common to all the problems. The next thing is one of its edges of the base. So it is resting on HP with one of its edges of the base. So when you say one of the edges of the base, so the initial position where you are going to start with the top view, the square should have a base which should come to your right. It should right. Okay, please remember it is totally reverse of the planes. So in planes it was in left side. Now in the solids, it should be right side. Okay. And the base, and this edge is inclined to VP at 30 degrees. So he was given the condition that that base edge is inclined to VP at 30 degrees. Draw the projections of the prism when the axis is inclined to HP at 45 degrees. So the conditions are resting on HP with the base edge is inclined to VP at 30 degrees, and the axis of the prism is inclined to HP at 45 degrees. So all these three conditions should be satisfied. So since we are starting from the top view here, okay, so first you are going to draw the true shape and true size of the base, which can be seen in the top view. First, the axis is perpendicular to HP, or the solid has been placed on HP. Okay, so first we are going to draw the base, the true shape and true size of the base, and later onwards we are going to project it for the front view. And in the second position, we are going to show how the axis is inclined to HP at 45 degrees. Okay, so 45 degree inclination with respect to HP, we will going to show in the front view, and correspondingly we will going to draw the top view. And in the third position, we will going to incline the edge of the base to VP at 30 degrees, and later we will going to project it for the final front view. So in the initial position when you are doing, okay, so the base edge, what you are going to draw, it should be perpendicular to the XY line. You have to construct in such a way that it should be perpendicular to the XY line in the top view or in the horizontal plane. And so we are going to start it now. Okay. So I hope you people could able to understand the problem statement. A square prism, 35 millimeter side of base and 65 millimeter axis length, rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the prism when the axis is inclined to HP at 45 degrees. Okay, I will just rotate this and I will go to explain this. See, this is the problem statement. This is the projection of a solid. See here, the initial position. First, you draw the XY line, mark VP and HP. Okay. Now, we have to construct this, or we have to draw the true shape and true size of the solid. So, how to draw this? So, when you take a square-based prism, okay, square-based prism, so the top face you will going to have it as A, B, C, D, and correspondingly you will have a base which will be A1, B1, C1, D1. This is how we will going to represent it. So as I told you, I just discussed in the previous slides for the triangular prism. So just A, B, C, D is in the top and D, E, F in the bottom. Same thing I am going to represent here. It's a square-based prism. It is not D, E, F. You are going to take it as the top face is A, B, C, D, and the bottom will be A1, B1, C1, and G1. So now, of course, in the top view, you can see the true shape of the square. So you can see only the top face. The top face is a square of 35 millimeter side, A, B, C, D, and correspondingly you will have the bottom base, which is A1, B1, C1, and D1. See, the edges is AA1, BB1, CC1, and DD1. So therefore, when you are giving the annotations in the top view, so you can see here A, it is a top view point, top base, and A1, it is a line which coincides, which is a corresponding point on the bottom base. Similarly, look at here B, B1, C, C1, D, D1. So the annotations A1, B1, C1, D1, which are there in the parentheses, they corresponds to the square at the base. Okay, and which are not in the parentheses A, B, C, D, they are at the top face. Because both these are equal and similar and they are parallel to each other. The top face and the bottom base, they are equal. So So therefore, we have a common to represent this. So this is the top view, and most important thing is the edge. The edge which is resting is A1, D1. A1, D1 is the bottom base, right? So therefore, I am going to say A1 and D1 is the bottom base edge which is resting on HP, and this edge should be perpendicular to the XY line. First, you have to start with the perpendicular to the XY line. You can draw with a different orientation. Okay, but you have to start with the perpendicular to the XY line. Okay, this is the top view. Okay, so now, so one important thing what I was talking is an axis. So axis should be shown over here. Look at here. So how we can draw the axis here. So axis should be exactly the center point. Therefore, to locate that point, so just join the opposite corners or draw the diagonals in the case of a square. Okay, it should be very thin line. So only the objective is to get the axis line, the projection where we are going to start. Therefore, draw these two lines with a very thin lines. Okay. So now we will going to get the projection. Point for the axis, and the top point of the axis is O, and the base point of the axis is O1. O and O1. So O is the topmost position point of the axis, and the bottommost position of the axis is O1. So O1. So this is how we can see. This is how we are going to represent. I think you people are following here how to start a square-based prism resting on HP on one of its base edges. So you have to construct a square of 35 millimeter side. Okay, this is the true shape and true size of the point. The next comes the front view. From the top view, you have to project it for the front view. So how do we get the front view? Just draw the projector lines. Okay, and then axis also should be represented. So axis. So we have 60 millimeter length, axis length. Okay. So therefore, you can see the front view of a square-based prism. So only the rectangle face. That's what I was talking in the previous example or demonstration. Only that rectangular face. When you just see from the front, this side from the front, you can see only A, B, B1, and A1. This is the rectangular face which can be seen in the front view. Okay, when you keep the solid on HP such that its axis is perpendicular to HP, and you can see one of the rectangular faces which is A, B, B1, and A1. And now we have to project it. So draw the projection, draw the projector lines, and we will going to get the axis line also. Axis length is 60 millimeter. So measure the axis length above XY line 60 millimeter, then project it, and you will going to get the front view. So this axis line should be a chain. It is not just like a, there should be a difference between lines with a visible line, invisible line, and the axis line. Okay, so this is how we will go into get the front view of the point. Okay, this is how we can just start doing this. This is very important, so please practice this. Okay. Yeah. Now, second thing what he says is, the axis is inclined to HP at 45 degrees. Axis is inclined to HP at 45 degrees. So this inclination of axis with respect to HP can be seen in the front view. So therefore, what we do is, this front view, the first initial position front view is there, no? That you have to draw it here. You have to show this is inclined to HP at 45 degrees. So how to represent these things? This is a very challenging task in our solids, because you have to tilt the solid in such a way that the base edge A1, D1 should be on the XY line. On the XY line. It should not go above the XY line. Okay, it should be, you are tilting the solid such that the A1 and D1 should be on the XY line or on the HP, and then we will going to tilt the lamina or tilt the solid such that the axis makes an angle of 45 degrees with respect to HP. Okay, this is the one what is very important for us. So please be careful. The point A1 dash and D1 dash should not go above the XY line. It should be on the XY line only. Okay, so then how to construct this? This is a challenging task for you people. So for that, very simple, I will explain here. The first what you can do, see, this axis is there, no? This O1 is an axis, okay? And it is perpendicular to this edge, am I right? This base, what I am talking about, the B1 dash and A1 dash, the base edge. This is 45, this is perpendicular. If this is inclined 45 degrees, means this should also be inclined 45 degrees. So therefore, first you construct this B1 dash and C1 dash, you measure a 45 degree and draw this line. Then very easy for you to construct this rectangle over there. So because we want to make A1 dash and D1 dash should be lying on HP. This is a very important thing. Therefore, you construct this base and then correspondingly you can get the other sides also. Okay. So this is how we will go into the initial position and correspondingly, and of course here you will going to show the axis is inclined to HP at 45 degrees. So once you draw the base, then you can just simply you can show this. This is very important. Okay, how you can do. Of course, this is can be done in a sketchbook, but in the case of when you are doing it on a software, then it is easy. You can copy it and you can directly get the things done. Okay, so this is how we will go into do it in your sketchbook. First, you draw a base edge, that is a B1 dash and A1 dash, which is inclined 45 degrees. Then correspondingly take the distances of this and you can mark them. Or you can draw, of course, you can draw this also, this line. That is A dash and A1 dash. This line is there, no? That also can be drawn for a 45 degrees here, because both are inclined 45 degrees. This also inclined to 45 degrees because axis and this edge are parallel to each other. So therefore, this also inclined 45 degrees. That can also be done. To draw this first 45 degrees, draw this line, and then you can correspondingly you can do. Either way, which you are comfortable, you can draw that line and you can get the things done. So after marking here, so then you have to get the corresponding projections of the front view, from the front view to the second position top view. So how we are doing? See here, the base, the top face is here A, B, C, and D, and in the bottom we have A1, B1, C1, and D. Okay, so the axis is O dash and O1 dash. So this is the top square and this is the bottom square. Top square is A, B, C, D, whereas bottom square is A1, B1, C1, D1, and correspondingly we have an axis O1 dash and O. So please be careful while you're drawing the axis. Look at here. It is a continuous, one is a longer line, other one is a smaller line. So like this you have to draw. Don't draw the dot here, it should be a very small line. So that is the difference between, see, look at this line, this axis line and the imaginary line, sorry, invisible line. Okay, so this is the continuous line. See, you have to draw one horizontal, one longer line, and another one is a shorter line. Longer line, shorter line. It should be a thin line. Like that, you're supposed to draw it. Okay, so then correspondingly, you can get the top view. So for to get top view, so you have to project, you have to draw the projector lines from each and every point what we have got, including the axis points. Okay, so now you are drawing this, and correspondingly from this front top view, initial position top view, draw the horizontal projectors, and here you should be very careful. See, the top square is A, B, C, D, and bottom is A1, B1, C1, D1. Okay, so the lines what it comes from the initial position top view, it is a common to the corresponding point. So therefore, where it meets from the front view, where it meets the top view, correspondingly you have to mark that, name it, and then you can start joining those points. Then you will going to get the final projection. So therefore, so what we do here is when you just draw the vertical projectors from the second position front view and horizontal projector from the first top view, the initial position top view. So now just you can see the horizontal projector A, it is coming over here, and vertical projector A is here. A1 both will be there. A, so it meets at here. Similarly, B is here and B is here. Similarly, C, D, like that. Here it will going to get. And similarly, look at here at the bottom base. See, A1 it is moving in this way, and A1 is here. B1 is here, C1 is here, D1 is here. Okay, when the solid is inclined to HP, when you look at from the top, you can see the different edges and different positions, different corners, and some might not be seen. So which are not seen, that we will go to represent it now. So now, so once you mark it, once you mark, don't join. Why? Because the rules of visibility needs to be applied. So once you start doing the projection of solids, the rules of visibility both in the front and the top views. So here we have projected for the top view first. So first we will going to complete the top view, and later and the next step we will have to get the front view. So in the top view, so how to apply, once you mark it, how to apply the rules of visibility. Yeah. See, look at, please listen to this very carefully. This is very, 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 very important, because visibility lines, if you don't represent, so you may deduct around 3 to 4 marks again. Axis, visible line, all are very important in the projection. So when you just observing, so this is a top view, you are getting a top view from this front view, right? So you are observing from the top in this direction. Okay. So when you just observe from the top, this base, this face is nearer to the observer. Am I right? So two important rules of visibility I told you, either in front or top view. The edges or the corners are nearer to the observer or visible, away from the observer or invisible. So this concept we should always know. Okay. So look at here, this top face A, B, C, D. Top face which is nearer to the observer. So when their edges are nearer to the observer, they are considered as a visible line. And also what happens to this rectangular face? See this rectangular face which is B, C, B1, C1. See, this is the rectangular face. This rectangular face, this line, what I am talking about, is also visible because it is nearer to the observer. Now, which are not visible for now. So, see this rectangular face A, A1, D1, D. This rectangular face and this base. Just look at this. This is A1, B1, C1, and D1. These two are away from the observer. These two are nearer to the observer, and these two are away from the observer. So nearer to the observer is considered to be visible, and away from the observer is considered to be an invisible. These two things we are supposed to remember. So correspondingly, you have to draw the lines. And this is the first rules of visibility what you have applied. And second rule is that, what the second rule says, if either it is a front view or in the top view, if any lines which is forming an outline, whether it is visible or not visible, it should be considered as a visible line. This is the most important thing here. Okay. So therefore, what we do here is, you look at here. Outlines, I am talking about the outlines. The outlines means the lines which will form the surface or the boundary, you can put it as, is a boundary. So the boundary edges or outlines, we can call it as boundary edges and the outlines, whether they are visible or not visible. So that should be considered as a visible line only. Okay. So therefore, so when you look at here, see, I will talk one by one. So here, A, B, C, D. Of course, this is a top face. This is a top face which is visible already, not an issue. We will go to join A, B, C, D with a thick continuous line. Thick continuous line. Right? Next comes what is CC1? CC1 is the edge which is forming over here, which is also visible. You are going to visible, no problem. And what about B1C1? B1C1 is this edge, of course, that is also visible. So what about BB1? BB1 is a forms another one, this line, which is also an outline, and of course it is visible in the top view. You can show this. And the last one is AB, of course, this one. And what about DD1? DD1 is away from the observer, right? Which is not visible, but visible line and invisible line will go into overlap. So when visible and invisible lines overlap, you have to show the visible line. Okay? When the two lines or two edges overlaps, one is visible edge, another one is the invisible edge. So it is customary to use or customary to show the visible edge only. So therefore, so when you look at here, DD1 is away from the observer in this position. So even though that is not visible, okay, but it overlaps with CC1 as well as CD. So therefore, we are not sure. And similarly, what happens to AA1 also? AA1 will go into coincides with BB1 and AB, and hence we are not showing those two invisible edges, even though they are forming. But even though they are forming in the sense, they will also form an outlines in this case. So therefore, it will going to be an continuous thick lines. Okay. Only the edge, what you cannot see here is A1, D1. So this corner is there now. This corner is away from the observer, and this corner is nothing but the edge here actually. So you are seeing in the two dimension it is an corner, but actually it is an edge, which is an A1, D1 dash. So you see A1 and D1 dash has been shown with a dotted line. Okay, this is an invisible edge. This is an invisible edge, and it does not form an outline here. Because outline only the boundary here. Boundary corresponds to the outline, and this edge is not an outline in this case. So therefore, so it is, we have to show this as an invisible edge. So invisible edge will be represented as a thick dashed lines. Thick dashed lines. This is how the completion of the second position, the rules of visibility. So both the rules you have to apply 1 and 2. Okay. So if any edge which are not visible and they are not forming an outline, not visible and not forming an outline, that should be considered as an invisible edge. Okay. This is how we have shown here. Okay. So I hope everybody is following. See if you find any doubts, any clarification, you can stop me. Okay, you can stop me and you can discuss with me. Okay. So this is the second position. And next comes the third position here. So in the third position, so we have to satisfy the condition that the edge on which it rests is inclined to VP at 30 degrees. Inclined to VP at 30 degrees. So which is the edge which is resting on HP? It is A1, D1. That's what I already told you. So that's why we, in the second position, we have tilted the solid such that A1, D1 should be resting on the XY line. So this A1, D1 is the one of the base edges of the square. Base edge, where the solid is resting on HP. So now, this A1 D1 should be inclined to VP at 30 degrees. So in the second position top view where it is, this is the dotted line, what we have shown an invisible line. It is the base edge. Okay. Now we have to tilt the solid in such a way that this base edge is inclined to VP at 30 degrees. So one thing when you are doing it on a sketchbook, especially the third position, okay, so be careful. Why? Because so the plenty of lines will go into game and the outlines will be a little bit larger compared to that of the planes, okay, and this top view, always the top view what you will go into write below the XY line should not cross, we should not go above the XY. So you should plan in such a way that, okay. So if you want to take any angles in the case of vertical plane, you can draw one parallel line to XY line. From there you can take 30 degrees. This is how we have done here. See, this problem how they have done, they are not directly taken from this position. Okay, so you draw the parallel line. From there you take 30 degrees, then you can, not an issue. Okay, so if this is inclined 30 degrees, it definitely will be inclined to 30 degrees. So now in the third position, what we do is to take a convenient distance below the XY line and make sure that, so why I am taking the convenient distance, because the not even a single point of the top view should cross the XY line above. Okay? So therefore we are taking here, it is a 30 degree line because the edge which is resting is inclined to VP at 30 degrees. So here we are taking 30 degree line, and in line with 30 degree line, first you are going to mark this A1 and D1. This is the edge which is resting on HP. Okay, A1 D1. So draw a 30 degree line. On that 30 degree line, measure the distance of A1 and D1. Of course, it should be equal to 35 only, but you mark it. So on 30 degree line, mark D1 and A1. Okay. Then correspondingly, with respect to these 2 points, the entire second position top view should be drawn. It needs to be transferred over here. Okay, so entire. So this is another one challenging task in the solids. So transferring from second position to the third position top view, second position top view to the third position top view. This is another one challenging task, everybody, and it is the place where it consumes lot of time. Okay. So all these first two is very simple. When coming to the third position, especially transferring. Because third position front view is also simple, but when it comes to a third position top view, when you transfer from second position to the third position, it should be clear. If this is clear, if this is correct, then the final front view will be correct. So I am talking, if problem carries 45 marks, okay, out of 45, so the final position, what you will going to get, it will carries 23 marks. 23 marks is given for this problem. Or 20 or 24, sometimes they will get 24 also. They have to equally divided. 24 and remaining 21 mark is for this. Therefore, so 50% of the problem, 50% of the marks is given to the final position. So be careful while you are doing in a sketchbook either in the printer or computer. So the final position plays an important role and it carries a maximum percentage of the marks. 50% carries marks out of 45. Maybe around 22 to 23 marks will be given for this final position. Okay, so therefore, when you are transferring from second position top view to the third position top view, okay, so be careful. Okay, so here the base edge is inclined to VP at 30 degrees. First, you draw a 30 degree line with respect to the VP, and on that 30 degree line, so mark the base edge which is resting on HP, which is A1 and B1. Okay, and correspondingly, you have to construct this entire outline and the lines which are inside this. So that is the transferring of second position top view to the third position. These are similar, but the edge is inclined to VP at 30 degrees. Okay, so you can take the convenient distance from each A1 and D1 and you can construct this. So once you complete this, then the final thing is projecting it for the front view. So draw the projector lines from each point where you have got from bottom base and the top base. Draw the projector lines, and similarly from the second position front view, draw the horizontal projectors. So again, here you have to be very careful while you are drawing the projector lines. And also, I'm sorry, I forget to mention the axis line. The axis line you have to represent. The axis line, how we are written in the top view here, same thing here also. So everything in each and every views, the axis should be there. Okay, be careful. Axis representation is very important. So when you project it, so this is the final front view. See, projecting it from A, B, C, D, A1, B1, C1, like this, everything you can draw and corresponding with the projector lines where it will going to get. First, you mark it because plenty after 8 plus 2, we have 10 points will be there. So you should be very careful while you position. Okay. So A where it connects, A, C, it connects here A dash, B dash, C dash, and D dash. This is the top face. And A1, B1, C1, A1 dash, B1 dash, C1 dash, D1 dash, it is the base. Okay, this is the base. Okay, so now when you project it, so this is the, when you join these points, this is the diagram. So again, we have to apply the rules of visibility for drawing the projector lines. Okay, so when you just see this square prism from the front, means you are observing from this side. So this is the front view. So this front view, the observer will be here, and the edge, base edge is nearer to the observer here, and the top face is away from the observer. It is just unlike what we discussed in the top view in the second position. In the third position, the front view, you are observing in this direction. Since the base edge or base is completely nearer to the observer, the base is visible in the front view. So you can see A1, B1, C1, and D1. They are with a continuous decline. Okay. Similarly, what happens to BB1? BB1 is also nearer to the observer, and here again you go to get BB1 is a continuous line. And what happens AA1? AA1 is also near, you can see in the front view. So you can see AA1. So this complete thing is visible in the front view. But what happens to the remaining surfaces and remaining edges? See here, C1. C1 is away from the observer, but in this case, it is forming an outline. Outline means C dash, C1 dash, D1 dash, A1 dash, A dash, B dash. This will form an outline from the top. Okay, so the outlines cannot be an invisible lines, whether it is invisible or visible, everything should be considered as a visible line only. So therefore, here what we are doing is, so we are joining CC1 with a continuous line. Okay. Next comes DD1. See, DD1 is not an outline for us. So therefore, we have shown this as a dotted line. See, one simple way to remember how to be invisible line means, which is the corner you represent. You just identify which corner is away from the observer, in this case, D. So the edges which comes out of D should be considered as an invisible edge. Very simple, blind way of representing is the edge which is away from the observer. The corner, you just look at the corner. Corner is D. The edge which comes out of D, they should be an invisible. Okay. So look at here. See, A dash and D dash is an invisible edge. D dash and C dash is an invisible edge. D dash and D dash, D1 dash and D dash and D1 dash, that is also an invisible edge. So mark it in this way. Okay. And of course, AD, even though it is not, it is away from the observer, it is not visible. A dash, B dash, even though they are not visible, so they will be taken as a continuous line forming an outline. This is how you can complete the projection of solids. Very simple problem I have taken. Okay. So you people need to do it on a sketchbook. Okay. So be careful while you are doing it, because lot of doubts and clarifications will come into you people. Okay. So once you practice it, and you can get the things done. Okay. So please try to practice these things, and if you have any clarification when you start next class, So please do it. Until unless you do, you never get a practice. Okay, until unless you practice it, you never get it. So once you get doubt, then things will become clarified. So if you don't do, then no doubts, no clarifications, no clarity. Okay, so therefore, be careful while you are doing it. So please do it very carefully and submit. Okay, next class I want to see these things. Okay, so please do it and show it to me. This is very important for you people and for me also, so that you can just complete the sketches. Okay, if you have any clarification, you can talk to me. Okay, before I just wind up. Anything, students? Anything to discuss? You can unmute and you can talk to me. If you have any clarification, you talk to me, my dear students. Okay, just practice it. Okay. So if you have any clarification, I will discuss in the next one. Thank you.